batteries. Any battery, actually it may have one or more than one cell connected in series. In a battery, there may be only one cell or more than one cell which are connected in series. So any battery or cell is a source of electrical energy, and this electrical energy is generated from the chemical energy of the redox reaction, and this redox reaction takes place inside a galvanic cell. So a battery or cell is basically a galvanic cell where chemical energy of redox reaction is converted into electrical energy. Chemical energy of redox reaction is converted into electrical energy. But what are the requirements of the battery so that it can be of practical use? First, it should be light. Second, it should be compact. And third, its voltage should not vary appreciably during its use. There are two main types of batteries. First one is primary batteries. In primary batteries, the reaction occurs only once, and after use over a period of time, battery becomes dead and cannot be reused again. Most familiar example of this type of battery is dry cell, which is also known as Leclanche's cell after its discoverer, and it is commonly used in transistors and clocks. The cell consists of a zinc container, and this zinc container acts as the anode. So zinc container acts as anode, and cathode is made up of graphite rod. So cathode is a graphite rod, and it is surrounded by powdered manganese dioxide and carbon. So cathode is of graphite rod which is surrounded by powdered manganese dioxide and carbon. Space between the electrodes, that is a space between the cathode and anode, is filled by a moist paste of ammonium chloride and zinc chloride. The electrode reactions are complex, but they can be written approximately as: what is the reaction at anode? At the anode, oxidation takes place, zinc changes to Zn2 plus ion and 2 electrons are given out. At the cathode, reduction takes place. In MnO2, the oxidation state of manganese is +4 and it changes to MnOOH. Here the oxidation state of manganese is +3. So manganese is getting reduced. So reaction at cathode is MnO2 plus ammonium ion plus electron forming MnOOH, and ammonia gas is given out. This ammonia, which is produced in the reaction, will form a complex with Zn2 plus ion to give tetraamine zinc ion. This cell has a potential of 1.5 volt. So this dry cell consists of zinc anode. The container is made up of zinc which acts as anode, and cathode is of carbon or graphite rod which is surrounded by powdered manganese dioxide and carbon. Space is filled with ammonium chloride and zinc chloride. Oxidation at anode and reduction at cathode. The ammonia produced combines with the zinc ion to give tetraamine zinc ions. So in the overall redox reaction ions are involved, because of which this battery becomes dead when used over a period of time, and it cannot be reused. Once these ions are used up, the battery becomes dead. Next is mercury cell. This mercury cell is used in low current devices like hearing aids, watches, and it consists of zinc mercury amalgam. This zinc mercury amalgam acts as anode and a paste of HgO and carbon as the cathode. This is the paste of HgO which acts as cathode. The paste of HgO, that is mercuric oxide, and carbon, they together act as cathode. The electrolyte is a paste of KOH and zinc oxide. The electrode reaction is: at the anode, zinc mercury amalgam plus 2OH minus ion changing into solid zinc oxide, water, and 2 electrons are given out. So it involves oxidation of zinc. Here in zinc mercury amalgam, the oxidation state of zinc is 0 and in zinc oxide it is plus 2. So this is undergoing oxidation. And mercuric oxide reaction at cathode is mercuric oxide plus H2O plus 2 electrons. This is reduction reaction. Changing into mercury, this is in liquid state, plus 2OH minus ions. So in mercuric oxide, the oxidation state of mercury is plus 2 and in liquid mercury it is 0. So this is reduction. Now in the overall reaction, when these two reactions are added, that is the oxidation reaction at anode and reduction reaction at cathode, if these two reactions are added, now 2 electrons on the product side and 2 electrons on the reactant side get cancelled. They are on the opposite side. 2 OH minus ions on the reactant side, 2 OH minus ion on the product side cancel, and the final reaction is H2O, H2O. They are present on the opposite side, they also cancel, and final reaction is zinc mercury amalgam plus solid mercuric oxide forms a solid zinc oxide plus mercury in liquid state. As can be seen, the overall reaction is not involving any ions. So its voltage remains constant during its life, that is at 1.35 volt. So its voltage remains constant at 1.35 volt as the overall reaction does not involve any ion in solution whose concentration can change during its lifetime. No ions are involved in the redox reaction. So no change in the concentration, and since no change in the concentration of ions, its cell potential remains constant. There is neither decrease or increase in the concentration of ions, so cell potential remains constant. Zinc is the reducing agent. Itself it is undergoing oxidation, and mercuric oxide is the oxidizing agent. It is itself undergoing reduction.